tangent? Well, at least some things are the same.
Yeah.
Okay, so finding all your solutions. This one's going to work a little bit differently. Same setup, subtract 3. Divide by 3. And these are special triangles because you're not using your calculator. So where is tangent negative? Second and fourth. And what reference angle has a tangent of 1?
45.
45. If not, do y over x. Set it up. There's your 45. So 45 is pi over 4. So this is 4 pi over 4. This is 8 pi over 4. So what's this angle? 3 pi over 4. And what's this angle? 7 pi over 4. Now, notice tangent has a little bit of a different thing. Sine and cosine have been looking like this. You're going to get sine up here, or sine down here, or you're going to get cosine over here, cosine over here. They're never opposite each other. So we could technically say plus 2n pi, plus 2n pi, or we could take one angle and add what to it? N pi. Because isn't this just a half a circle from here to here? Isn't this just half of a circle to get there, to the other terminal side?
Mm-hmm.
So if it's opposite quadrants, all you have to do is add pi. But take the smallest angle. Take the smallest angle and add n pi, where n is any integer. Okay? Because you get to all these angles eventually, but if you just add n pi, it'll say 4, 7, and then it'll keep on going here and here, and we'll do that in a second when we do your all solutions. But it'll go 180, 180, 180. It'll keep going by your 180s. Make sense?
That's really only for tangents.
Well, anyone's that tangents, you're going to see tangents because they're opposite quadrants. Sine and cosine are right next to each other, so you're not going to see that. The only other situation we'll see is if we do a plus or minus and we hit all quadrants, then we can do like a sine from quadrant 1 and quadrant 3, and one from quadrant 2 and quadrant 4. But normally they're not across from each other. So now, if you need to do the solutions between 0 and 4 pi, what's your denominator? 4. Convert this to fourths. So 16 pi over 4. So we're going to start with this guy. And each time you're going to add n pi. So let's convert n pi to fourths. So just give me 4 pi, right? So each time we're going to add 4 pi. Oh, look at that. What's our next angle?
Wait, why are we doing 4 pi?
Because we're only going n pi away.
Oh,
We're going to convert it to fourths. It's not a double.
Alright.
So if I add 4, what do I get? Oh, isn't that my other one?
Look at that.
Look at that. Add 4 again.
11 pi.
And now watch how nice this is. Did I reach 16 yet?
No, you did not.
No, I did not. Can I add another 4?
Yep. 15 pi over 4.
Did I reach 16?
No.
No, but if I add one more, I'll be over. Now, let's see if this makes sense. I get 2 and 2 pi. 2 and 2 pi, how many should I get in 4 pi? If I get 2 and 2 pi,
You get 4
and 2 and another 2 pi, I should get 4 altogether. Do I have 4?
Mm-hmm.
Mm-hmm. Perfect, I have 4. So,
the way you worded that was a little weird. That's why we were.
oh, okay, sorry. So I get 2 in the original 2 pi, and 2 in another 2 pi, and 2 in another 2 pi. So every time I add another 2 pi, I get 2 more angles. And that's a nice way to check to see if you also have the limit, to know how many you're going to get. Just double that amount. Like if I'm doubling these or I'm tripling, sometimes we'll say to 8 pi, to 16 pi. Okay? Okay, one more. See if you could solve this next one. Just give me an x equals. We'll do the all solutions part. square,
We square root it.
square root it, and when you square root, what do you get? 1 over the square root of 3, plus or minus, though, right? When you undo a square, you get a plus or minus. So we're going to add 1. When you take the square root of anything, you get a plus or minus. And the easiest way is separate this, because it's not going to look very good like this. It's going to look a lot better like this. Because isn't this the sides of one of your special triangles?
It sure is.
Sure is. So I know I'm using all 4 quadrants. So let's just label the first one, y over x. What's my reference angle? 30. So if this is 30, this is 6 pi over 6, this is 12 pi over 6. So normally I would say 1 pi over 6. I would say 5 pi over 6. I would say 7 pi over 6. Then I would do the last one, 11 pi over 6. I would have 4 angles that from 0 to 2 pi, right?
Yeah.
So now, I need to do all solutions. So all I need to do is look for the ones across from each other. I don't need to add 2n pi to each one of those. I could, but it's kind of redundant. I'll keep hitting the same angles. So if I take this one, and I add n pi, I'll get this angle. So take the original, add n pi, and we'll just qualify it over here. Okay, now, if I take this next guy, I'll put the star out here, which one do I also hit? The one across from it, right?
Yeah.
So I just need to take this one and do n pi. Do I really need to keep track of those guys? Do I need to qualify these?
No.
No. Because all I need are these 2. And that works if you have a sine, or a cosine, or a tangent in all 4 quadrants. You're always taking the opposite quadrants, because isn't that 180 degrees away? Pi and pi,
Yeah.
right? So this gives you all solutions. If I wanted all solutions between 0 and 4 pi, I would change my denominator to 6. I would just keep adding it to the first one, then I would add it to the second one. And I will get all my solutions between 0 and 4 pi. Make sense? I don't have to do all 4 of these for the 2n pi. Because once I'm across from each other, clear across, half of the circle, that's 180, that's pi. So let's say I want to go from 0 to 4 pi. Let's throw that in. What denominator am I using?
6.
6. So convert this into a denominator of 6.
24 pi over 6.
Good. So let's take your first one. I'm going to add n pi. Take n pi and convert it and convert it to 6. What do I get? 6 pi over 6. So every time I'm going to add 6 pi. So add 1. Add 6 to this. I already have a 1.
Pi over 6.
And isn't that the other one that I crossed out?
Yeah.
Right? Add 6 again.
13 pi over 6.
And I didn't hit 24. Add 6 again.
19 pi over 6.
And if I added 6 more, I'd be out of my range.
Yeah, you would.
So I stopped there. And doesn't that make sense? I did 2, and the 2 pi I should do 4. So now, the next one, 5 pi over 6. Add 6.
11 pi over 6.
Add 6 again.
17 pi over 6.
Shouldn't I be able to get 4 on this one also?
Yeah, if you add you would get 23.
And you get 23 pi over 6. So do you see a pattern? Okay. All we really threw at you this time was find all solutions, or find more than just from 0 to 2 pi. You guys always knew 0 to 2 pi. You know how to find those solutions. You knew where tangent's positive and negative, where sine is positive and negative, where cosine is positive and negative. And now we just made this cycle go, because aren't your curves continuous?
Yeah.
They go on forever. So when I'm looking for all solutions, this is an easy way to find my all solutions.